Hello everyone, welcome back to another presentation. We're going to talk about transformations, symmetries, and tilings. And this is Module 4, Chapter 11. So first off, we're going to start with question number 1. A student attempts to reflect the given shape. Let me move my face. A student attempts to reflect the given shape, explain what they did wrong and how to find the correct solution. So to the left of our screen, we see a shape in a box. That is our original shape. And if you look a little bit to the right, you'll see the student's solution. Well, based off of the student's solution, they did a 180-degree rotation. They didn't actually mirror it like they were supposed to or reflect it. So this would be called a reflection, which is not what we're looking for. Instead, we want the correct solution, which is going to be this image right here. And that's actually a direct mirror from our original shape, which means that will be the correct solution. Next, for question number 2, we are going to identify the lines of symmetry, if any, in each given shape. So if we'll look at our first one, we don't see any real kinds of lines of symmetry here's how we're going to explain lines of symmetry. A line of symmetry is a line put through a shape that whenever you mirror one side of the shape over the other, they're exactly the same. So with our first shape, we don't have any lines of symmetry, but with our second shape, we have 2 lines of symmetry. And with each line going through that shape, when you mirror that, say the line going through the middle, when you mirror that top over the bottom, it's just the same thing. Our third shape doesn't have any lines of symmetry, while our fourth has 3. Our fifth shape is only going to have 1. Our sixth shape is only going to have 2. Seventh, only 1 line of symmetry. There's really nothing else you can split there. And 8 has, let's see, 1, 2, 3, 4, 5, 6 lines of symmetry. For question number 3, do the following shapes form a vertex figure? Well, if we look at our shapes, we'll notice this indentation right here. So yes, of course, a vertex figure is basically it's the corner point of a polygon formed by the intersection of other shapes. Question number 4, are line segments PQT and PST congruent? Well, Q and S are going to be the same distance apart from the line PT that splits through that line. And from then on, we just kind of draw out our figure. If you'll notice, since Q and S are both the same distance apart from line PT, they are going to be congruent whenever you draw out those shapes or those lines. For question number 5, we are going to connect the points N, E, P, A, and T and figure out what shape is made. So if we'll look to the left, I already went ahead, I connected all the points. Since this shape has 5 sides on it, it's going to be called a pentagon. Next, we're going to connect the points Q, P, and R and figure out what shape is made there. Well, P, Q, and R, when connected, make a triangle. Next, we're going to connect our next set of points right there. And this is the figure we're going to get when we connect those. For question number 6, how tall is the cliff given that Jenny, the observer, let me look at that real quick. How tall is the cliff given that Jenny or the observer is 1/4 mile away and her ruler that she's using is displaying 1.5 inches of height for the cliff? Well, we automatically know that 1 mile is 5,280 feet. So we're just going to find 1/4 mile, divide that by 4, and you'll notice that'll give us 1,320 feet. So next we're going to look at our ruler. We have 1.5 inches, which is 0.125 of a foot. So we're just going to get our 0.125, multiply it by 1,320, and we get 165. Next, we're going to divide that by 4, and we'll notice that our cliff is 41.25 feet tall. Other than that, that's really it for today, and I hope you enjoyed the lesson.